We are the trustworthy bridge builders, and our project was the Collapsible Bridge.
Going into our project, we knew we would be following the design process, which begins with asking questions about goals and requirements and doing research. The Collapsible Bridge project had numerous requirements and constraints dictating certain aspects of our build. The two main requirements were that the bridge must span 5 feet and hold a minimum of 60 pounds. The main constraints include the bridge must weigh no more than 5 pounds, it must fit within a 1-foot cubed box when disassembled, and it must be able to be assembled and disassembled in under 60 seconds. There were also other miscellaneous restrictions that were less impactful, such as that it must be at least 1 inch wide and that PVC is not allowed. We initially looked into 3 bridge types: truss, arch, and cable stay. Truss bridges are effective when spanning shorter gaps, with the only contact with the surface being at each end. However, they require a larger volume of material than other designs, which may mean that the design is out of reach given our constraints. Arch bridges utilize the least amount of material. However, when downward pressure is applied, it creates a significant amount of outward force. This can be troublesome due to our bridge being required to sit on top of 2 tables, solely supported at each end, as it can lead to the end sliding out, causing the bridge to collapse. Lastly, we looked at cable stay bridges, which use tension from wires suspended from towers to support the bridge. We decided to use wood due to its good strength to weight ratio, and to make an arch bridge due to its low material requirement, combined with a wire connecting to the base of each side to counteract the outward pressure created by the arch. We also planned to use hinges to connect each of the pieces together, and we decided to start with 7 8-inch pieces with an 8-degree angle between each piece as an estimate. We created a 3D model with our original estimates, which we then tweaked to find the optimal piece length and angle. After some testing, we decided on 7 10-inch pieces with a 10-degree angle between each piece. We also decided to use small wooden dowels inside of each piece to connect the pieces together rather than hinges, as it would help reduce weight and cut down on assembly time. Here we used a miter saw to cut each of the 7 wood pieces to length, as well as ensuring each of the pieces were cut precisely at a 10-degree angle. We then lined up each of the pieces to ensure our cuts lined up properly. Lastly, we drilled holes in the end of each block of wood for the wooden dowels to get placed into. We used a metal stopper to ensure that the depth of the hole was perfect for the length of the dowel. To test the strength of the bridge, we placed it on the ground and applied weight to the middle in the form of a push-up. After multiple tests to ensure it worked as intended, we then disassembled it to be weighed, which came out to be about 8 pounds. At this point, the only improvements left to make were to cut weight to reach the 5-pound maximum. This was done by drilling out the sides of the wood, making sure to not go all the way through in order to preserve as much structural integrity as possible. We continuously drilled, re-weighed, and retested the strength until our bridge weighed only 5 pounds. After weeks of research, planning, and construction, we had a final product which met all of the requirements and constraints and performed exceptionally.
On Fed Day, we placed 3rd in our session. We were one of 5 groups that held the maximum amount of weight, and the only wooden bridge to hold it all, without any assistance. It took around 20 seconds to set the bridge up, but if you include the time we spent adjusting the tension rod, we completed setup in 40 seconds.
If we had to redo our project, we would want to change the amount of time it took us to set up on competition day. We spent a lot of time adjusting the tension rod, and it wasn't really a waste of time, but we took twice as much time to set the bridge up than we really should have, which lowered the amount of points we could receive for that one category. In addition to this, we would have liked to have tried using different design methods that would have maximized the amount of weight our bridge held while minimizing the weight of the bridge. Additional points were given for bridges that weighed less than the 5-pound limit, so we shorted ourselves in this category by having a bridge that weighed exactly 5 pounds. So if we had the opportunity again, we would have liked to have been able to decrease the weight of our bridge even more than we did to meet the original requirement. When all was said and done, our bridge held 147 pounds, hands-free, without showing any signs of failure.
Freshman advice from those at Trustworthy Bridge Builders. Things to do and not to do. Do not wait. Projects will take longer than anticipated due to unexpected problems, conflicting schedules with teammates, and other circumstances, so do not hesitate to start working early. You will thank yourself closer to Fed Day. Additionally, take advantage of the resources made available to you, as they will help you tremendously. Such resources include the craft centers, maker spaces, and other workshops whose sole goal is to help students build things. Also take advantage of your specific project's guru. They know your projects inside and out, and they can help with ideas, concepts, what was effective in the past, and how good of ideas you already have. Follow directions extremely carefully. Often the difference between placing and not is simply following directions and meeting all the requirements. The judges do pay attention to every small detail, no matter how important it may seem to you at the time, and those details will affect their scoring of your project. For example, certain groups with the collapsible bridge did not consider several requirements, such as the 5-pound limit, and though their bridges succeeded and excelled at holding the weight, they were held off the podium for not meeting the requirements. Enjoy Fed Day. Take time to walk around the McKinnon Center and admire the hard work and innovation of your classmates. It is very fulfilling to take in others' success, see ideas you hadn't thought of, and see the wide array of projects at Fed Day other than your own. Similarly, it is not all about winning. Sure, it's fun, but it's only a t-shirt. The experience and innovative environment surrounded by all your friends and future counterparts in the engineering field is much more important than your pride, so be sure to take it all in.